So basically, the example of a job statement is going to look something like this. In the event that we have an installation-defined set of values, you can see we would have the job name, job indicating the operation, and then you can see the accounting information here that we have specified. Now, in the absence of any specific definitions about an installation standard, these values right now, as they indicate here, are completely arbitrary. But as I said, if you have an installation standard, then you would get the information about what needs to go in there from that standard. You can see the programmer name field has a value in there called my name. Since there is a space separating the two words, it's enclosed in single quote marks. If I was using the JES accounting information, in this case here I have the programmer accounting number of 1022, I have a room number of 222, I'm indicating an estimated execution time of 5 minutes, the amount of output is estimated to be 5,000 lines, and then I am leaving out the cards and the forms, indicating I want 2 copies, a Y indicating that I do want to include the JES log, and then 60 lines of printout per page. Now, in this situation, again, these estimates, for example, are just that. They do not have to be extremely accurate, but they basically establish a bounds so that if they are exceeded, JES will issue warning messages on the system console that the job has exceeded those particular values. Now, again, in most shops, there are standards that govern this particular behavior, and one of the reasons why this is not used very frequently is that the installation may well have defined default values that they want to use for all jobs, and as a result, whenever you exceed those estimated values, then warning messages will be issued, and operations can make a decision to either notify you or to cancel a job, or, depending on if it's production or test, whatever action the installation is deemed appropriate for that particular situation. So remember, installation standards are going to govern virtually everything that is going to be coded on the job statement. Now, both of these values, the programmer name field and the accounting information, have no specific technical requirement. Therefore, they are going to be completely defined by the installation requirements. Now, standards will also govern the values that are going to be used in the various keyword parameters, but again, this is going to be a combination of either installation-defined defaults or specific values that need to be coded in order to comply with your installation's requirements. So one of the very first parameters that we have is a class parameter. And a class parameter basically indicates that we can specify a value of A through Z or 0 through 9. We have 36 values here that can be specified. And what these values represent is the initiators that are used to run work will be assigned a class or several classes that they service. Therefore, the installation will establish a class for you to use, whether it be for production or whether it be for testing, and as a result, using that class will ensure that the proper initiator picks it up. In the event that there's not enough initiators to handle that, again, it becomes installation policy to determine whether more should be started or whether your work simply gets delayed because there's too much work going into those particular initiators. But this is going to be one of the parameters that you would code on your job statement. So again, we also have a value then for output data. Our message class in this case indicates the output queue that work is going to go to. Again, we have 36 options, A through Z, 0 through 9, and the installation will establish standards. Now, in this particular case, too, it becomes important that you're aware of what those standards are, since output classes can be defined as either active classes where things will actually be printed, they may be a held class, which allows for online viewing, there may be classes designated for automatic archiving, and there may be classes designated as dummy classes, meaning that the output is thrown away for anything that goes into that class. So you want to be aware of what classes to use for your particular jobs. As we said, the installation standards are going to govern the legitimate values that we want to use for these purposes. The message level parameter indicates what data we want to allow in our output. In particular, we have the statements that are going to be produced as well as the level of messages that are going to be produced. So for example, we can indicate we only want the job statement and comments printed. We want to print all of the JCL statements, or we want to print only the JCL and exclude any symbolic substitutions or expansions of other statements. Generally speaking, option 1 is the one that you want since it includes all of the information that's pertinent to your JCL, so that in the event that you have an error or you have anything you need to debug, then generally speaking, this is something that allows you to get the most complete view of everything that you've submitted. In addition, the messages themselves indicate whether or not we want to print only JCL messages or other error messages in the event that we experience an abnormal termination, or we want to include all output messages. So in general, the setting for the message level is going to be a 1,1, indicating that we want all JCL statements, expansions, symbolic substitutions, and all output messages produced. Now this is a value that is often set as a default value in the installation, which means that if it has been coded or specified as a default, you do not need to specify it on the job statement. Very often you'll see it specified even if it's not required, but in general, this is going to be one of the considerations that you have about what required parameters are. So don't allow it to confuse you in the event that you see it on one job statement and you don't see it on another job statement, and you may be wondering, well, why didn't it produce an error? And the reason being is that many of these parameters, in fact, do have system defaults, so that if they are not coded, they will simply revert back to the installation specified value. The notify parameter. In this case here, this parameter is intended to direct any completion messages back to the user or back to whoever submitted the job. And you can see in the simple example here, we can simply use the user ID so that we can get our message back indicating when the job is completed. We can also specify a node name, and in that node name, this is going to allow us to specify a user ID on a different system than the one that we were running on. And so it basically allows the system to send a message across to another connected system to notify that user of the job's completion. The indication here of coding an ampersand sysuid is a symbolic parameter that has global meaning that we can code in our JCL so that it allows substitution of the current user ID. Rather than hard coding a user ID, this is often a useful way of coding this on a job statement. In some situations, individuals may have more than one user ID. So by specifying this, it ensures that the one that they are actually currently logged into is the one that receives the notification message. The region parameter assigns an upper bound to the amount of virtual storage that we can request for this particular job. Now, the thing to keep in mind here is that when we are requesting virtual storage, we are not actually using all of the storage that we have specified here. We are simply placing an upper bound on the amount of storage that can be requested for this particular job running. Again, there are installation defaults that are normally specified, and as a result, if we don't code anything here, we will get that installation default. In the event that we find that our job terminates because there's not enough virtual storage, then we would code a region parameter to indicate the amount of storage that we want. Installations may also establish upper boundaries in terms of what you can request, and as a matter of fact, if we use this value, we can also code 0 to indicate that we do not want a limit. So that way, if the installation does have a limit coded, then what will happen is that when you have the 0K or the 0 meg, you will be allowed to request any amount of memory up to that particular physical limit. And so this provides a way then of where if you're uncertain how much storage you need, but it is greater than the default, then coding this can be a good way of working around that uncertainty and getting the job to be able to run. The time parameter represents the time in CPU usage. So in other words, this is not wall clock time or elapsed time. This is the amount of time that you are actually using the processor. And you can see it can be specified in minutes or seconds. And we can also specify 1440 or no limit or the maximum, which would all represent the elimination of timing or setting maximum values for CPU usage. This parameter also is going to be subject to default settings. So generally speaking, we would not code this unless we had a requirement to either increase the amount of time that we have available, or we were using it for testing purposes and we wanted to ensure that we could stop a job running in the event that we went into a loop. So we might set some very small value there to ensure that we didn't exceed or waste a lot of time by looping. For the most part, though, again, the installation standards will largely be what determines what this value should be. As we said, this is not elapsed time, and this does not relate back to the JES accounting information, which was an estimated elapsed time value. This literally refers to CPU time. In addition, when we specify things like low limit or time equals 1440, that actually turns timing off, which means that not only does it not restrict us in terms of CPU time, it also means that we are not going to be impacted in the event that we start to accumulate large amounts of wait time. Because again, the installation can have default values that force a job to terminate in the event that it waits too long or that it consumes too much CPU. So both of those will be turned off by specifying an unlimited value like that. The maximum value basically ensures that you could run at CPU times of up to 248 days, which for all practical purposes would represent literally years and years and years of running. So it's not a value that we concern ourselves with. Most of the time it's simply going to be another way of expressing what we normally consider to be unlimited time.